Okay, in the first half of this lesson, on that last video, we talked about how you can solve just by factoring. Well, they all aren't going to work out so nicely, and where you can just factor by grouping or factor with the greatest common factor and traditional factor or something like that. Sometimes the exponent values are higher. Sometimes you have more solutions than you can find by factoring. And in that case, we will need to use Desmos, because remember, wherever the graph crosses the x-axis, that is where a solution to your polynomial is, okay? So in this case, you're going to use Desmos to find the real solutions, those places where it crosses or touches the x-axis, and then we are going to synthetically divide in order to find the rest of the solutions, okay? So here's how it works. So if you synthetically divide, okay, that means it goes in evenly into your polynomial and there is no remainder. And if there is no remainder, then that value is a solution to the polynomial. So the first thing we're going to look at is one that just shows how that's true. Okay, so the first thing we're going to do is look at our problem, and we say x to the third plus 7x squared plus 16x plus 12. Normally we would say, oh, there's 4 terms, let's see if we can factor by grouping. But if we factor by grouping, it is not going to work out where you're going to be able to find solutions that way. So what we can do is we can actually put our equation into Desmos, and I did that already over here. You will need to do that on your homework, okay? I did not cut and paste all of the graphs for you for your homework. You'll have to go into Desmos, put your equation in, and you can go ahead and do that right now. If you want to pause the video, you can go and put your equation into Desmos to make sure you get the same graph that I do. Okay, but what we're going to do on this first problem only is just show you that these places where it crosses and touches the x-axis are the 3 places that are the solutions to the function, okay? So we know, based on our fundamental theorem of algebra, that there are 3 solutions, okay? And if we look at our graph in Desmos, we notice that it crosses at -3, okay? And it bounces at -2. So remember, when it touches but doesn't cross, that's a repeated solution. So we'd have repeated solutions at -2. Okay, so the 3 solutions to our equation here are going to be -3, -2, and -2. And in order to show that that's true, we can use synthetic division. And as long as we get a 0 for a remainder every time we synthetically divide, that means that it is a solution. So here's what that looks like. Remember how to synthetically divide. We put -3 up here, and then we draw our line. We have all of our exponents there, 3, 2, 1, 0. So we're going to put our 1, 7, 16, 12. Bring down our 1. 1 times -3 is -3. We get -12. -12, and we get a remainder of 0, okay? What we are left with is 1, 4, 4, okay? Which means what we have now, I'm going to kind of show you how this works, is we have factored, it would be x plus 3, okay, because we know that -3 is a solution, and we'd have 1 x squared plus 4x plus 4, okay? So what we had left after we factored out that -3 was x squared plus 4x plus 4, okay? So now we are going to take what we had left over and we're going to synthetically divide by our next solution, which is -2. So we've divided by -3, now we're going to divide by -2. So I'm going to put -2 in here, go like that, and I'm going to put the coefficients of this part, which is basically these right here. So I'm going to put 1, 4, 4, and I don't need to put the 0. So I'm going to bring down the 1, -2, I get 2, -4, I get 0. Okay, so now I have done the first -2. So now what I have is I have x plus 3, that's this one. This -2 would be x plus 2. And then my leftover here, I have x plus 2 again. Like if I was going to write that, it would be x plus 2. But just to show that that's the case, we're going to take this last -2 and we are going to divide 1, synthetically divide, bring down our 1, -2, 0. Okay, and all we are left with is 0, with a remainder of 0. So once we get all done, we showed that if we factored out -3, -2, and -2, we got zeros every single time, which means our three solutions are going to be -3, -2, and -2. Now, when we're actually going to be doing some solving, it's going to look a little bit different, but that's the idea that we are going to use moving forward. Okay, so let's take a look at another one here. Again, we've got a fourth power, which tells us that we are going to be looking for 4 solutions using our fundamental theorem of algebra. I went ahead and copy and pasted the Desmos file in here, which is over here on the right. And our Desmos tells us that we should have real solutions at 0 and 1. So we know that we are going to be at x equals 0 and x equals 1. Okay, those are the two real. Now we have to actually synthetically divide, and I'll show you how that works here. We're going to synthetically divide in order to find our other solutions. Okay, so I know if I divide by 0, which I know if you're a math person, you're thinking, I can't divide by 0. Well, we can synthetically divide by 0, and we can put in our coefficients, 1, -1, 9, -9, and remember we have to have place fillers for everything, even our constants, so we have to have that 0 on the end. Okay, so I'm going to bring down my 1 and multiply, add, and multiply, add, and multiply, add. Oops, there we go. And so I end up with 1, -1, 9, -9. So now I have divided by 0. Our next step is going to be to divide what we left off with by our second 0. And the easiest way to do that is to put our next 0 right here on the outside of it, because we're just going to divide out positive 1. Oops. We are just going to divide what we had left over. So I'm not going to rewrite everything. I am just going to leave my coefficients, because those are the coefficients of my last division problem. So I'm going to bring down my 1. 1 times 1 is 1. -1 plus 1 is 0. 0, 9, 9, 0. So now I have left here, I have 1, 0, 9. Okay, so what we need to think about is, how can I write 1, 0, 9 as an equation, or as an expression? Okay, well, we started out with a fourth power, divided out 0, so now we started out with a fourth power, divided out, we're going to have a third power, and so now we have 1, 0, 9, which means I'm going to have 1x squared plus 0x. If we want to put that in there, we can go ahead and put in our place fillers, plus 9. And remember, we're finding our zeros, so we need to get it set equal to 0. So I'm going to kind of just simplify what we just wrote a little bit here. X squared plus 9 equals 0. And this, remember, came from these numbers right here. Okay, so now if I need to solve x squared plus 9 equals 0, I'm going to subtract 9 from both sides, and I get x squared equals -9. Take the square root of both sides, and I get x equals, so our other two solutions come from the fact that it's going to be plus or minus, and the square root of -9, remember we need to take out that I with the square root of -1, and then the square root of 9 is going to be 3. So we would have plus or minus 3i. So our 4 solutions are going to be 0, 1, 3i, and -3i. Okay, let's take a look here at another one. All right, how many solutions are there? Well, we've got a 5 for a power here, so we know there's going to be 5 solutions. If we look at our graph, okay, we notice it bounces at -1. Okay, so we know that -1 is going to be a repeated solution, so it's going to be in there twice. And then 2 is our other solution, because it crosses at 2, bounces at -1. Okay, So we use Desmos to find our real solution. We found our repeated at -1, okay? And then we're going to go ahead and synthetically divide in order to get down to the point where we can solve to find our last two imaginary solutions. So we'll use our first one. We're going to use -1. We'll put that in there. Our coefficients are 1, 1, -2, -12, -8. And, oops, what did we forget here? I'm going to have to adjust a little bit. I am missing a power. I am missing a fourth power, which means I need to fill that in with a 0. 1, -2, -12, -8. Bring down my 1. Then I have -1. Multiply negative times negative is positive. 2 times -1 is -2. -4 times -1 is +4. And -8 times -1 is +8, and I get a remainder of 0. Okay, so I've synthetically divided by the first -1. Now I'm going to synthetically divide by the second -1. So I'm going to just put my -1 here, use the coefficients I just created. I don't need that 0 anymore because that was my remainder. I'm just going to synthetically divide again. Bring down my 1, -1, -2. -2 times -1 is 2. 4 times -1 is -4. -8 times -1 is +8, and I get a remainder of 0. Good. All right, now I've synthetically divided by both -1s. Now I'm going to synthetically divide by 2, so I'm going to put my 2 right here. And synthetically divide again. Bring down my 1. -2 plus 2 is 0. And then I have a 0, 4, 8. And I got a remainder of 0 again. Okay, so now I have synthetically divided by all 3 of my real zeros, and I'm left with 1, 0, 4. Okay, so I started out with a fifth power. Okay, divided it out, or I started with a fifth power, divided it out, got a fourth power. Divided again, got a third power. Okay, and so now what I'm left with is a second power, so I'd have 1 x to the second power plus 0x plus 4 equals 0. Again, just like last time, I'm going to rewrite that a little simpler. X squared plus 4 equals 0. If I subtract 4 from both sides, I get x squared equals -2. And then again, when I take the square root, that's where my last two solutions are coming from, the plus or minus. Remember, the square root of -1 is I, and the square root of 4 is 2. Oops, 4 is 2. So we'd have plus or minus 2i. So all of our solutions are going to be x equals -1, -1, 2, positive 2i, and -2i. And if you count them, there's 5, just like there was supposed to be. Okay. If you're confused on how you get to this last place and how to solve that or anything, please let me know and raise your hand. Otherwise, we can move on and look at your homework. Okay, your homework is in Schoology. It is a worksheet where you're going to be doing synthetic division and solving just like this. There's about 5 or 6 questions, I think. And when you get done, just submit it back into Schoology. It's the actual worksheet is a link in the Schoology assignment. So then you can just open it in GoodNotes, finish it, and submit it back. Good luck.